says these two curves then are transformed using this pair of transformations here, a reflection in the x-axis and a reflection in the y-axis. If something is reflected in the x-axis, then the whole function, the output, the y value, becomes the negative. So if you think about an x squared graph and a minus x squared graph, they've been reflected in the y-axis. So this is a reflection in the y-axis, sorry, in the x-axis, because the y values change. A reflection in the y-axis it's the x value that gets flipped over. So f of x goes to f of minus x. So if we do those two things for our graph, if the x axis reflection takes place first, then x bracket 2x plus 5, all of that just gets times by -1. So it becomes, after the first reflection, negative x bracket 2x plus 5. So this is the x-axis reflection. The y-axis reflection then takes the x values and turns them negative. So every time you see an x, we're going to write minus x instead. So how does that affect the graph? Well, we're going to end up with, this is going to become positive again, so we're going to end up with x times minus 2x plus 5. Or you could write that as x bracket 5 minus 2x. The inverse cos function, so that was originally this, is going to go to the negative inverse cos function, but then the x again is going to go to, so the negative inverse cos of negative x. So those are our two new graphs. So our two new graphs, it says state the equations of the two new curves and determine the coordinates of the point of intersection. Well, if we think about our graph from part 1 here, how's it going to look different? Well, we're going to, let's just look at the quadratic one. That's going to flip in the x-axis, so it's going to do this. And then it's going to flip in the y-axis, so it's going to end up here. And the point of intersection that used to be over here is now going to be down here. So this point that we now know is 0.242 then is going to be negative 0.242. So we don't really even need to worry about the inverse cos function. We don't need to work out where that will be, because we can get everything we need from the quadratic. So we know that the x value of the point of intersection is going to be negative 0.242. So point of intersection will be when x is negative 0.242 and if we substitute that into our function that we've got for the new quadratic, so this x bracket 5 minus 2x, we should get the y coordinate. Now I've pressed my calculator a few more times to get the most accurate value for x that I can, just because I like to be super accurate. Obviously I've times that by -1 now as well, but the x, so when I substitute, so I've got on my calculator minus 0.2418916,517, and I'm going to use that number for the x value. So I'm now going to take that number, I'm going to times it by 5 minus 2 times the number that was on my screen, and that gives me a y value of minus 1.33 to 3 significant figures. So we've got an x value of minus 0.242 and we've got a y value of minus 1.33.